Let's quickly understand the problem. And hey, if you are here just for the code walkthrough, feel free to skip ahead, but for intuition, approach, and why this works, stick around. So today, we'll be tackling the problem find first and last position of element in a sorted array. Here's the problem. We are given a sorted array of integers and a target value. We need to find the starting and ending position of the target in the array. If it's not present, we return -1, -1. For example, if the array is 5, 7, 7, 8, 8 and 10 and the target is 8, then the output should be 3, 4. Here's the intuition. Since the array is sorted, this is a perfect case for binary search. If you are not familiar with how binary search works or its time complexity, I've created a quick video breaking it down. You'll find the link in the description. But here's the catch. We don't just need to find the target once. We need to find both its starting and ending positions. So here's what we'll do. We'll slightly modify our binary search. When searching for the first occurrence, if we find the target, we don't stop immediately. We move left because there might be another occurrence earlier. We keep narrowing down until the search space is empty and whatever value we are left with is guaranteed to be the leftmost position. Same logic for the last occurrence. When we find the target, we move right, checking if a later occurrence exists. This ensures we log onto both boundaries efficiently. Here's the strategy. We'll perform two binary searches, one to find the first occurrence and another to find the last occurrence. And we'll use a small helper function to handle both by passing a flag is first to switch the behavior. Before we dive in, pause the video and give this a shot yourself first. Try writing the code on your own, then come back to compare. Alright, let's walk through the code step by step. We start with the search range method. We initialize an array to hold a final answer. By default, we set both the values to -1 in case the target isn't found. Next, we call our helper method findBound twice. Once to find the first occurrence and once to find the last occurrence. The third parameter, true or false, lets the helper method know which side we are searching for. Now let's see how findBound works. We start our binary search range from left is equal to 0 to right is equal to n-1 and initialize bound as -1 in case the target isn't found. Then in the core binary search loop, we compute the mid index using left plus right minus left by 2 to avoid integer overflow. If you are not sure what does this mean, make sure you watch the binary search video. The link is in the description. Now the key check. If we find the target at mid, we store it as a potential bound. This is the important part. If we are looking for the first occurrence, we shift our search to the left half because there might be another occurrence earlier. If we are looking for the last occurrence, we shift our search to the right half because there might be another occurrence later. This is how we ensure to get the exact leftmost and rightmost positions. And if the element is less than or greater than the target, we adjust our search range as usual in binary search. We return the index we found or -1 if the target was never found. The time complexity here becomes O of log of n because of the two binary searches, and space complexity is O of 1 since we are using constant amount of extra space. Log this one because this boundary tracking binary search technique pops up in several important interview problems. Follow Coding60 on Instagram and on YouTube for more quick coding breakdowns. And drop your next problem in the comment.